Hello everyone, my name is Saurabh Singh and today I am going to teach about the clay mineralogy and soil structure. And this is going to be very important topic of geotechnical engineering. As you can see here, today we are going to learn about the mineralogy and soil structure. Now we will see the learning objective and learning outcome of today's lecture. Today you will know about the clay mineralogy and you will understand what is the soil structure, and you will also understand what are the application of clay mineralogy and soil structure and how it involved in the planning, analysis and design of foundation of soil improvement techniques. And there is also learning outcome where you will understand the knowledge about the geotechnical engineering which is applied in the designing of structure, and you will also learn about the theoretical and practical aspect of geotechnical engineering which is used in the soil clay mineralogy and soil structure. There is outline. We will see what we will cover today here. First, we will see clay mineralogy, identification of clay minerals, specific surface, interaction of water and clay minerals, interaction of clay particles, soil structure and fabric, soil fabric natural soil fabric clay soil fabric granular soil, loses segregation. After that, we will see MCQ and references. Now we will see the clay minerals first. As you can see, origin of clay minerals. The contact of rock and water produce clay either at or near the surface of the earth. So, if anybody will ask you what is the clay, then you can answer it is rock plus water. For example, the CO2 gas and the CO2 gas can dissolve in the water in the form of carbonic acid, which will become hydrogen's ion H plus and bicarbonate ions and make water slightly acidic, which will be equal to, like, if you will see the chemical formula of this, it will be CO2 plus H2O. It will become H2O CO2 and H plus HCO3 ion. The acidic water will react with the rock surface and tend to dissolve the K ions in silica form of the feldspar. Finally, the feldspar is transformed into the kaolinite. And now note that will be the hydrogen ion displace the cations. And the alternate of feldspars into kaolinite is very common in the decomposed granite. The clay mineral are common in the filling materials of joints and faults in the rock mass. Now we will see the mixed layer clay. Different types of clay minerals have similar structural properties. So, of the layer, different clay minerals can be observed. In general, the mixed layer clay are composed in stratification of expand water-bearing layer and non-water-bearing layer. Monomineralic elite is the most common, and chloronite, willemite, and are the these are the minerals which is obtained in the soil. Now we will see the volume and weight volume relationship of a soil. For this topic, we need to know the following. Mass is the measure of body of inertia, or it is a quantity of matter. Mass does not change at different places. And as you know, weight can be changed on the different places due to the gravity small g, but mass will be always remain same in everywhere. Like if you will weight yourself on moon, your weight will be less, but mass will be but your mass will be same. Now we will see W will be equal to m into g, where g is the acceleration due to the gravity, which will be equal to 9.8 meter per square second, 9.8 meter per second square, and density will be represented by the rho, which will be equal to mass upon volume. And unit weight of soil will be equal to weight upon volume, which will be equal to mass upon volume. Now come on the next point, unit weight and density. What is the difference between unit weight and density? This is also very important to know for all the civil engineering students. The SI unit of mass density, which is represented by the rho in kilogram per meter per cubic meter, and it will be equal to kg per meter cube. The SI unit of force of Newton, therefore, the unit weight of soil are typically expressed in kilonewton per meter cube. Relation between unit weight and density here is also which will be equal to here uh, gamma, which will be gamma, which is showing the density of a soil. As you can see here, it is showing the density of soil, and the density of water, which will be shown by the rho, shown by the rho. And you can see here, it will depend on the temperature at the 4 degree Celsius. Water density is equal to 1000 kg per meter cube and 1 kg per centimeter, as we all know. And then unit weight of water will become 9.81 kilonewton per meter cube. Now we will see the soil phase. Soil deposits comprise accumulated soil particle plus void space between the particles. The void space are partially or completely filled with the water or the liquid. Void space not occupied by the fluid or filled with the air or other gases. Hence, soil deposits are referred as a three-phase system, which is known as solid, liquid, and gas. Now you can see this is your soil particle, which is represented by here. Soil particle, solid particle is represented by S, and air particle is represented by A, and there is also some water which is represented by W, which you can see here. Now this is the phase diagram as we saw in the previous lecture, and this is the phase diagram of fully saturated soil, which will which will help you to understand what is the two-phase diagram. And this is the two-phase diagram of a dry soil, which is where no presence of water in this sample. Now we will see some example of here, which is related to three-phase, and it is the neutral state. The moist soil has total volume of, which is given here, 9344.56 centimeter cube, which is 9344.56 meter centimeter cube, and mass is given here, which is 18.11 kg. The dry oven mass of soil is 15.67 kg. If GS is given here 2.67 for the soil, then you have to calculate the moisture content and moist unit weight and void ratio and degree of saturation of a soil. So you have to solve this by the using of this diagram, this formula. By this numerical here, you can see the total weight is given here, which is equal to 18.11 kg, and the Weight of solid is given 15.67 kg and weight of water is given 2.44 kg. Now we will see the total. If you will see the total volume is given here. It is 9,344.56 centimeter cube. And if you will see the total uh, total volume of solid, it is 5,868.9 centimeter cube. If we will calculate the total voids, it will become 24 to 2,440 centimeter cube, and there is a volume of air and voids, it is 3,475.66 centimeter cube. So by that things you can easily solve the numerical. And now we will see the relationship between various physical properties of a soil, which is mentioned here. All the weight volume relationship needed in soil mechanics can be derived from the appropriate combination of six fundamental definitions. They are void ratio, porosity, degree of saturation, water content, unit weight, and specific gravity. The use of phase diagram in finding physical properties. Remember the following simple rule. Remember the basic definition of water content, void ratio, specific gravity, and degree of saturation. And you also need to know about the three-phase diagram, how to draw a three-phase diagram. Assume either volume of solid is equal to 1 or volume of Wt is equal to 1 or weight of solid is equal to 1 depending on the value. Solve the phase diagram for the required value. Now as you can see here, this is the if E assume as a Vs is equal to E, then it will become like this. As you can see here, if W assume if W will assume as Ws is equal to 0, it will become like this. Now we will see here the relationship between E and N. Here you can see E will be equal to VV upon Vs is equal to V upon V minus VV. And finally, by the solving that things you will get here N is equal to N upon E upon 1 plus E. And here porosity you will get VV upon VT plus E upon 1 plus E. That will be your formula of porosity. And there is also one relationship between void ratio, degree of saturation, water content, and specific gravity, which will be equal to W. W upon Ws is equal to gamma W into VW upon Vs and gamma S. And here we will get the finally relationship between specific gravity, void ratio, and as you can see here, there is also water content. It will be become Se is equals to Wgs. This is very useful relationship for solving three-phase diagram relationship. Now we will see the relationship among ESW and GS, and it is given in the textbook as you can see here. By these things you can easily derive the relationship between specific gravity, void ratio, and water content by this. Now we will see the relativity density. The relativity density is the parameter that compare the volume reduction achieved from the compaction to maximum possible volume reduction. The relative density dr, also called density index, it is commonly used to indicate inside denseness of the loose soil or granular soil. As you can see this graph is showing the different volume reduction in the granular soil. As you can see in the figure 1, there is more this is not more compacted soil, that's why there is more white. There is some compacted soil, that's why there is some air voids which is less than this graph, and this is fully compacted and We can also call it densest state soil, where is less soil, and you will say it is in loosest state and it is in intermediate stage, and this is in densest stage. And this diagram is showing volume reduction from the compaction of granular soil. Now dr can be expressed either in the terms of void ratio or dry density. Dr will be equal to E max minus E, E max minus E minimum, where Dr is representing relative density, usually given as a percentage. E in the site void ratio of the soil is the maximum void ratio of soil in the loosest state, and E minimum is the void ratio of soil in the densest state. Now we will see some derivation. You can solve this derivation by these using this formula. And granular soil and quantitatively described according to their relative densities, which is shown below. As you can see, there is relative density is given of very loose soil, medium soil, dense soil, very dense soil. And the use of relative density has been restricted to granular soils because of difficulty of determining Emax in clay soil. Liquidity index in the fine soil of is similar use in DR in the granular soil. There are some remarks which you need to know. The relative density of natural soil very strong effect in the engineering behavior. The range value of DR may vary from minimum of 0 for loose soil maximum to 100% for heavy dense soil. Because of the irregular size and shape of granular particle, it is not possible to obtain zero volume of voids. ASTM test designation D-4253 D4254 2007 provide a procedure of determining maximum density. This formula by this numerical here you can see the total weight is given here, which is equal to 18.11 kg, and the weight of solid is given 15.67 kg, and weight of water is given 2.44 kg. Now we will see the total. If you will see the total volume is given here. It is 9,344.56 centimeter cube. And if you will see the total uh, total volume of solid, it is 5,868.9 centimeter cube. If we will calculate the total voids, it will become 24 to 2,440 centimeter cube, and there is a volume of air and voids, it is 3,475.66 centimeter cube. So by that things you can easily solve the numerical. And now we will see the relationship between various physical properties of a soil, which is mentioned here. All the weight volume relationship needed in soil mechanics can be derived from the appropriate combination of six fundamental definitions. They are void ratio, porosity, degree of saturation, water content, unit weight, and specific gravity. The use of phase diagram in finding physical properties. Remember the following simple rule. Remember the basic definition of water content, void ratio, specific gravity, and degree of saturation. And you also need to know about the three-phase diagram, how to draw a three-phase diagram. Assume either volume of solid is equal to 1 or volume of WT is equal to 1 or weight of solid is equal to 1 depending on the value. Solve the phase diagram for the required value. Now as you can see here, this is the if E assume as a Vs is equal to E, then it will become like this. As you can see here, if W assume if W will assume as Ws is equal to 0, it will become like this. Now we will see here the relationship between E and N. Here you can see E will be equal to VV upon Vs is equal to V upon V minus VV. And finally, by the solving that things you will get here N is equal to N upon E upon 1 plus E. and here porosity you will get Vv upon Vt plus E upon 1 plus E. That will be your formula of porosity. And there is also one relationship between void ratio, degree of saturation, water content, and specific gravity, which will be equal to W. W upon Ws is equals to gamma W into Vw upon Vs and gamma s. And here we will get the finally relationship between specific gravity, void ratio, and as you can see here, there is also water content. It will be become S is equals to WGS. This is very useful relationship for solving three-phase diagram relationship. Now we will see the relationship among ESW and GS, and it is given in the textbook as you can see here. By these things you can easily derive the relationship between specific gravity, void ratio, and water content by this. Now we will see the determination of bulk density. This topic is also very important for civil engineering student. Here we will see what is the bulk density first. To determine the bulk density, we need to measure a dry mass and total volume occupied by the soil sample. And this is the method of determining the bulk density. First one is the core cutter method. As you can see here, this is your core cutter method, and a cylindrical metal sampler is driven into the soil removed known as the volume core. As you can see here, they have to put it on the soil and they will put it out. Then they have to take the soil sample. The core, which will be include soil plus brass cylinder, is oven dried at 105 degrees Celsius to remove non-structural soil water till the mass remain constant, usually after 24 to 28 hours. Now you can see these are the some equipments which we use in the core cutter method for determination of bulk density of soil. As you can see here, that is your cutter, and from this cutter we have to take the sample like this, and which will be undisturbed soil sample, and this is then it will go in the dry oven at the 105 degrees Celsius. After that, do the weight of this soil sample, and we have to remove the moisture content. And here you can see the volume of cutter will be equal to volume of T will be R square pi H. This is a simple formula of determining the volume of a cylindrical thing. Now we will see the example of a core cutter method. Here is R, which is given here 3 centimeter, H is given 12 centimeter, and MS is given 480 gram oven dry mass. And VT will be become here R square pi H, which will be become 3 square 3 into 14 into 12. As you can see here, this is your 3.14. This is your value of pi, which you can see here, and it will become 339 centimeter cube. From here we have to find rho pb, which is bulk density. Bulk density will be mass of solid upon mass of volume of sample will be equal to total volume, which will be equal to 480 gram upon 339, which we determined volume already here, and mass we already given here, and it will become 1.42 gram per centimeter cube. That will be your bulk density of soil. This example is very important. If you will write any government exams, these types of question and examples may be asked to you. And this is, as you can see, this is a very easy. By this formula you can easily determine the uh, total bulk density of soil. From here you have to calculate the volume of your cylindrical cone, which will be equal to r square pi h, and it will become here 339 centimeter cube, and mass is already given here, which will be equal to density will be equal to mass upon volume. Then we will get 1.42 gram per centimeter cube. Now we will see the execution excavation method by the sand funnel. The quantity of soil is excavated in the field dried at 105 degrees Celsius and weight. The volume is determined by the filling excavated hole with the well-defined standard sand, of which volume per unit mass is known as sand funnel method. As you can see, this is your sand funnel method, which is used for the excavation purpose. Now, excavation method, you will also see there is also one balloon. In the rubber balloon method, the volume is determined by the inserting the balloon into the excavation and filling with the water and other fluid is known as density. As you can see here, that is your water travel, and that is your valve, and that is your rubber membrane, which is fit on the end of the this scale, or you can say this is this water tower. Now we will see the next topic here, engineering classification of soil. This is also very important, and we have done some points in the previous lecture. So let's see again what is the engineering classification of soil. What is the purpose of doing the classification? Classification soil into group and subgroup with the similar engineering behavior. Classes, classification system were developed in the term of simple indicate, which is showing GSD. And now we will see the purpose of soil classification system. Classification of soil into groups, subgroups with the similar engineering behavior. Classification system were developed in the terms of indicate GSD, and as I told you earlier, this classification can provide geotechnical engineering with the general guidance about the engineering properties of soil through the accumulated experience. And as you can see here, this is your flow chart of a soil classification system, where what is the need, which is showing the need of soil classification system. In this here we will see these soils, and these soil are categorized into many parts, and there is also many reason of the failure of structure due to the soil behavior. And if you think, if I give you a bag of if I give you a bag of 1 kg soil taken from an under construction site and asked you following question. So by this you will learn what is the meaning and what is the basics of a soil classification system. That's why these questionnaires have been written here. I did this questionnaire for your understanding, basic understanding. A question is given here. If I give you a bag of 1 kg soil taken from the under construction site and asked you following question, what is the most basic classification of soil? What are the method of soil gradation and grain soil distribution? How do you define the soil of types? And clay, silt, sand, gravel, cobble, and boulders. Calculate D10, D30, and D60 for this soil by the using of CU, and calculate both CU and CC of the soil. Is this soil poorly gap or well graded? Liquid limit, plastic limit. How do you define these terms? Means these are the basic questions which is very important for every civil engineering student, because when you will go for your work, when you will get a job, when you will do a work on your field, then these types of questions can be asked by your senior, and there will be a need there. You should answer all these questions. You have to answer all these questions, and you will learn today in the class what is these meaning of these questions. First we will see CO analysis. What is the purpose of doing CO analysis? This test is This test is performed to determine the percentage of different grain size contained within a soil. The mechanical or sieve analysis is performed to determine the distribution of the coarser, larger side particle, and hydrometer method is used to determine the distribution of the final particle. What is the significance of sieve analysis? We will see here the distribution of different grain soil affect the engineering properties of soil. Grain size analysis provide the grain size distribution and it is required to classifying the soil. These are the major group of the soil group. As you can see here, cohesive soil, granular soil, cohesionless soil. There is silt, clay, sand, gravel, cobble, and boulders. These are the grain size soil. Soil particle classification is given here, and these are the organization which given method in the soil classification. Now we will see the grain size distribution, which is also known as GSD, and we will see what is the significance of a GSD to know the relative proportion of different grain size. An important factor influencing the geotechnical character of coarse grain soil, not important in fine grained soil. These are the significance of a GST, means grain size distribution. Now we will see the how to determine the grain size distribution, how we perform this test. In the coarse grain soil, by sieve analysis, fine grain soil by the hydro analysis. As you can see, if soil will be coarse grain, then we have to do the sieve analysis. If the soil grain will be fine, we have to do hydrometer analysis. And as you can see here, this is the hydrometer and this is your image of a sieve analysis. Sieve analysis where gravel will be here, sand will be in this sieve, and fine soil will be in this sieve. Now you can see the image of ISC, which is here, and these are the sieve ISC which have different size. Now we will see the sieve designation. What is the meaning of large sieve designation? As you can see, this is the size of this sieve is 3 inch, and this is larger. This is used for the larger size boulders, and this can be also used in the sieve analysis. Now sieve designation. We will see here if smaller sieve are numbered according to the number of opening per inch. As you can see, this is the sieve and number 10 sieve, which is known as number 10 sieve, and the size of hole is here 1 inch, as you can see here. Sieve procedure. What is the sieving procedure? We will also see it. Sieving procedure, and these are the sieving procedure. Place the sieve stack in the mechanical shaker and the shake for the 10 minutes. Remove the stack from the shaker and carefully whisk and record the weight of each sieve within the retained soil. In addition, remember weight and record of weight of the bottom pan with its retained fine soil. This is the method of putting a sieve, uh, and we have to do it like first one. The size of this sieve will be more, like it will came from the bigger to smaller. Like first one is bigger, after this is the smaller, after the bigger, after the bigger, and this will be your set of sieve. Means you have to fix sieve like this. Now you can see this is your sieve shaker, which is used for the shaking of a soil, and this is your weighing machine from you will weight your soil sample. And how you will do the data analysis of sieve, you have to also know it. Obtain the mass of soil retained on each sieve by the subtracting the weight of empty sieve from the mass of sieve plus retained soil, and record this mass as the weight retained on the data sheet. The sum of these retained mass should be approximately equal the initial mass of soil sample. A loss of more than 2% is unsatisfactory. Calculate the percentage retained on each sieve by dividing the weight retained on each sieve by the original sample mass. Calculate the percentage passing by the starting with the 100% and subtracting the percentage retained on each sieve as the cumulative procedure. As you can see, this is the chart of sieve analysis from where you can find what is the number of sieve and what will be the size of this sieve here. As you can see here, like 4 number sieve, there is 4.75, 5 number sieve which has size 4 mm. These are the number of sieves, and these are the graph which is showing the calculation of doing the final for the determination of final particle in the soil. And you can also say if this is soil deposits and grain sieve size analysis. Now this is the sample of a test data where we have to do this kind of analysis. As you can see, 4 number sieve, 10 number sieve, and these are the percentage of passing from each sieve. For example, the total mass is given here 500 gram. Mass retained number of sieve is 9.7. For the number 4 sieve, quantity of passing will be equal to total mass minus mass retained. It will be for 90 gram. This is the percent. How you will calculate the percentage here? Percentage retained is equals to mass retained total mass. You will find how much percentage is retained in the sieve number 4, which you can find from here. And this is a graph of sieve analysis, and by this graph you have to plot this graph in the Excel, and there is also many videos on this grain size distribution graph from where you can learn how to plot this diagram of sieve analysis, which is related to clay mineralogy. There is first question. In the liquid limit test, the moisture content at 10 blows was 70% and that at 100 blows was 20%. The liquid limit of soil is, what will be the right answer here? Right answer will be C. It will be 65%. Here your right answer is 65%. Now come on the next question. The active earth pressure of soil is proportional to, what will be the right answer? Where phi is given as the angle of friction of a soil. Option is given here, 4 optional, and here right answer will be C, which will be equal to tan square bracket 45 degree minus phi by 2. That will be your right answer. Come on the next question. The minimum water content at which the soil just began to crumble when rolled into the threads of 3 mm is known as, what will be the right answer? Liquid limit, plastic limit, shrinkage limit, permeability limit. Here right answer will be plastic limit. As you can see here, right answer is plastic limit. Come on the fourth question. Pick up the correct sentence from the following. The rise of ground surface due to the frost action is called frost haze. The freezing of water accompanied by the volume increase of 9% below the freezing point, higher soil suctions develop. The magnitude of all frost haze decrease as the degree of saturation of soil decrease. All of the above. Here right answer will be all of the above, means all which is given here, all sentence which is given here, they are correct. Which of the following sentence is correct? Here we have to answer it. Clay are more porous than sand. Pressure of organic matter in soil decrease the bearing capacity of soil. Aluminous cement is used for foundation in the soil with the chemical deposition all of the above. Here right answer will be all of the above. Come on the next question. The lateral earth pressure of a retaining wall. What will be the right answer? It is equal to mass of soil retained proportional to the depth of soil proportional to the square of depth of soil proportional to the internal friction of soil. None of these. Here right answer will be none of these. That will be your right answer. Means the lateral earth pressure of retaining wall is equal to the mass of soil retained, and it is also proportional to the depth of soil, and it is also proportional to the square of the depth of soil, and it is also proportional to the internal friction of the soil. That's why your right answer will be E here. Next question, the internal molecular attraction of soil, the cohesion, decrease the moisture content, increase the moisture content, decrease, no, is more well compacted clay, depend upon the soil, depend on the external load. Here right answer will be C, it is more in well compacted clay. So right answer will be C. The quantity of seepage of water through the soil is proportional to coefficient of permeability of soil, total head loss through the soil, neither A or nor B, and both A and B. Here right answer will be D. Both A and B will be right answer here. When drainage permitted under initially applied normal stress only and full primarily consolidation is allowed to take the place is test known as quick test, drain test, consolidated, and drain test. None of these. Right answer will be C here, consolidated and drain test. That will be your right answer. Come on the 10th question. The minimum water content at which the soil remain its liquid state and also poses a small shearing strength against the flowing. It is known liquid limit, plastic limit, single limit, permeability limit. Here right answer will be liquid limit. That was the MCQs, and these MCQs is very important. They maybe came in the government exam, and they maybe also came in your weekly test. Now it is time to give the reference of a geotechnical lecture. There is also one NPTEL link which is very good. If you will watch this video, you will understand more about the geotechnical engineering. There is one book which is written by the VNS Murthy. That is the references for today's lecture. And thank you for watching this video.